All right, hello and welcome back to my attempt to learn how to make a roguelike by learning the roguelike toolkit through learning the entity component systems and learning Rust. Quadruple layer learning system here, so let me see if I can show you my screen. There we go. So what we've gotten so far, we've done the introduction to teaches us how to do or how to build for web, as in addition to just building a standalone executable. We can actually build a web-based game. So this is running in my browser, but it's all Rust code using Mosm, and you can see we've got the game going here. It's building rooms and corridors, and it's creating monsters. The monsters don't do anything, but you can see that it's highlighting what we can see, and it's remembering where we've been. So we can see the room and the dungeon layout. And so far right now it's just a single layer, and if I hit refresh it'll generate a new dungeon. And that's as far as we've gotten. We've just started, as of last session, started the monster AI system. So we're just going to continue. I was going to go over the specs book, but maybe I'll save that for once I get stuck with how the entity component system works, how specs works. RLTK, you can see it here, uses specs in order to implement the toolkit. So you have the entity component system as a generic library, a crate, that RLTK uses to implement its toolkit. And what did we do last? So we had this last. Oh, it's being slow. Okay, there we go. So we, that's a no op. So we added monsters for the first time. So that must have been up here, right? Yep. And we spawned monsters. And monsters were considering their own existence. Let me see. We should pull up the. Oh, I need to update Chrome. I'll do that later. Yeah, monster considers their own existence. So if the monster is visible, right, it'll do that. Right, refresh. It starts again. So they're running every single tick. They're considering their own existence. So burning a lot of CPU, doing nothing. But that's what the monsters are doing now. And here's the beginning of the AI system, is where we print that out. So every tick part of the game will run the monster AI system here, and that's part of the tick code. Let's take a look at that. Source libmod. And this probably belongs to its own file, but right now it's just in the top level of the library, where we have run systems runs every tick. We get the player input, we run the systems, we clear the screen, we draw the map, and then we draw all the items on the map, and then that's the game. So what we're looking at now, right, so we've done this. I put in some new lines just to make it easier to read rather than having just a blob of text. You can actually see, because I imagine there's going to be more systems. I peeked ahead, there are more systems. Okay, so now we're going to go to a turn-based game in a tick-based world. To prevent this, if you cargo run your project now, it will be very slow, and your console will fill up with monster considers their own existence. All right, so Chrome is being nice and joining them all together, right? The game is either running or waiting for input, so we make an enum to handle this: run state, paused, or running. Okay? Where does that go? Maybe it's time. Maybe now is the time to restructure this. Put this in its own game state. Because what have we got so far? We've got components map. You've got the top level of the library, monster AIs. We got the player. We got a whole rectangle class, which just implements intersection and center. And then we have the visibility system that we worked on. So if I make a game state, right, and put this, we need game state in RLTK, specs prelude, and then what do I do to pull in, for example, if I look at map, I just say create : : star. It's kind of a cheaty way to do it, but that's what we'll do. Use create. If build times get to be too long, then I can fix that, right? So now in mod, we can get rid of all this. How much of this can we get rid of? All the way up to here, right? And then we have to say pub mod game state, pub use game state : star. And that should pull it in. So this should still build, right? Oops. Forgot I moved. Build, there we go. Unused import, so we don't need game state there. Lib mod.rs. I'm surprised we need RLTK. Maybe we don't. Let's see what breaks if we don't pull that in. No, everything breaks. Oh, because this uses it. So let's fix that. Lib player. So RLTK and virtual keycode. There, much cleaner. Okay, and if we hit refresh, everything should still work. Monsters still consider their own existences. And it's all good. Nice. All right, so I've done that. So now I can put this run state in the game state code, right? Oh, but this is, run state is not, well, no, actually it goes right there. Okay, that's fine. Oh, of course. Source lib. There we go. So we have pub struct state and we have pub struct. We're going to derive partial equal copy and clone pub enum run state, and it's paused and running. And then we're going to put it in here. Pub run state, run state. Okay. Right, I understand about how derivation works. Partial equal allows you to compare equal or non-equal. And clone adds clonability. Copy makes it copyable. Sure. Next, we add it to the state structure, and in turn, we need to amend our state creator to include a run state running. Okay. So I think that's in main. Source main. There we go. I thought it was. Oh, if we build it, it'll fail, right? World new. Right. Okay. I was getting lost there. And then run state, running. All right. Does that build? It does not. Oh, because I put a semicolon there instead of a comma. So finicky. Okay, so now we change our tick function to only run the simulation when the game isn't paused. and otherwise to ask for input. So if run state is running, run systems, run state is paused, else run state is player input. Okay. And that is tick function. So it's these two here, player input or self-run systems. So we're going to swap those around. If self-run state is run state running, then run the systems and switch to paused. Run state paused. Otherwise, we're going to set this run state to whatever the result of player input, which does not yet return anything. As you can see, player input now returns a state. Here's the new code for it. So, boom, boom, boom. If it's anything other than underscore, then return paused, otherwise return running. Okay, we can do that. Source lib player. And where is here? Right? So this changes. Oh. Right, we're going to have this return. So this goes away. Oh, I see. Okay. Can I? Yeah, I can just return it from there, right? So change this to, oh, let's do doing a return. Okay, run state paused. It's a return statement, and then if it doesn't match, we can just say run state running. And that should work, even though it's an if, because the if doesn't have, the if can return a value. I'm pretty sure. Does this build? Boom. It does not. Expected, I found a new, oh, because I forgot to say it has a return type. Right? So in player, we have to say returns run state. Oh, and I found expected, oh, because of fall through. Okay. So we can just say that. No, yeah, we can, because this returns here and then this falls through and then we just say running. Okay, that works. Perfect. So now let's see if they consider their own existence. They do. So every tick they're considering their own existence. And every so often I hit left or right and it stops working. So I broke something. What did I do wrong? Git diff. Right. So that all changed. But what happened here is, where's all my, oh, my new code isn't in the git diff. Right. Source lib game state. So if run state is running, then run the systems and then set it to paused. So if self-run state is not running, anything other than running, then we set run state to player input and we do this. So we shouldn't run the systems when we're not running. It looks like the return value from player input is not working right. Player.rs. I have it backwards? No, run state running. If there's no key, we go to running. If the key didn't match, then return paused. Launch cargo run now, the game is back to speed and the monsters only think about what to do when you move. Oh, no, I missed this part here. Oh, okay, here we go. That's what happens. So this, oops, I hit SS instead of DD. Like that. There we go. So else, I missed the none case there. Run state paused. Like that. Silly me for refactoring the code prematurely, right? All right, let's see if this works. All right, we got 11 monsters who we have considered their existence. And if I hit move, it should go to 22. Yeah, look at that. Okay. And they're all considering their own existence as I walk. But if I freeze in place, like a weeping angel, it no longer considers its own existence. Okay. All right, so that's working. So git add source, git show, git diff staged. All right, so we have our new file. We have removed that code from the mod. And then we change this so that we can return paused or running depending on the player's actions. We're still running this code every tick, but if we return paused, then we just go back and look for player input and we don't run any systems. Okay. That's fine. Cargo format and cargo clippy. Ooh, not happy. Okay. Unused import. I like unused imports. It means removing lines of code. We don't need specs prelude for this. Good. Git status. Oh, we did reformat some code. So put a new line there. Put those on separate lines. And sorted these. Okay. Git add source, git commit -m. Only run systems after player input. Here we go. Quiet monsters until they see you. All right. You could let monsters think every time anything moves, and you probably will when you get into a deeper simulation, but for now let's quiet them down a bit and have them react if they can see the player. It's highly likely that systems will often want to know where the player is, so let's add that as a resource. In main.rs, one line puts it in. I don't recommend doing this for non-player entities. There are only so many resources available. Huh. I didn't know there was a limit on resources. That's interesting. But the player is one we use over and over again. Okay. This is where I have to go back and look at the specs book and learn about how it handles resources and why there are limits on resources. But that's for another stream. All right. So we're just going to add the player source main as a resource. Where do we create the player? All right. So we've created the player. I see we're inserting the map here. Let's insert the player. GSECS insert. Oh, we're just adding the player's position. Oh, not the whole player, but just the player's position. Player X and player Y. That bothers me a bit because now we have two locations for the quote truth of the player, right? We have the position here of the player. That's a component on the player's entity, and then we have this resource that's inserted into the ECS data management system that has the same exact thing, and then we have to keep them in sync. That's sketchy. Source lib player. So in try move player, we update the resource when the player moves. Okay, so after we do this, and then we say let mute ppos, ECS right resource point. So it gets the one and only point resource from the ECS. Pos y is equal to pos. Oops. Glad I caught that. That would have been weird. Then we can then use that in our monster AI system. Here's a working version. Blah blah blah. If viewshed visible tiles contains player pos. Oh, okay. So it's grabbing the player's position here. It's finding out what the viewshed of the monster is. It's looping over all player positions, viewsheds, and monsters. I still don't understand the difference between read expect and read storage. And there's also write storage and write expect. Anyway, so it grabs the data. It loops over every monster with a viewshed, right? Then if the monster's viewshed contains the player position, we're going to shout insults. Okay, let's do that. Source lib monster AI system. So we don't need the monster's position anymore? Or maybe that's coming later. All right, well, let's get rid of it. Let's add in read expect. Take a point. And point, the only point that's a resource is the player's position. So that's how that works. So we don't need that anymore, but we do need player pos. For viewshed and monster, in viewshed and monsters, if viewshed.visibleTiles.contains ampersand star player pos. So this dereferences the player pos because it's a reference to a point, and then we're going to pass in a reference to that. Not sure the details behind that, but instead of the monster considering their own existence, the monster is going to shout insults. Right? If your cargo run this, you'll be able to move around, and your console will gain monster shouts insults from time to time when a monster can see you. All right? Or not. What did I break? Oh, the viewshed shouldn't have an underscore. Oh, we don't have point. That's why. So we have to add point to our monster AI system, right? I thought that would be in specs prelude, or did I create the components? Point? No, it's under RLTK. Okay, so do this. This happens when I hit F1 by accident. Console point. But that's not the only error, right? This is not used. So let's get rid of position. And there's probably another error too. Yep. And player RS doesn't have point. Source lib player. So we have to add that. RLTK virtual key code and point. What else? Okay, that's because of that. Viewshed visible tiles. Unknown field. Are you sure? Well, let's rebuild it with the fixes. No. What did I do here? Oh, we have to do it. We have to do it up here. Okay. like that, because I put it outside the for loop because I figured, well, we'll loop over all of that and then update it, but pause is inside this, so we have to update it every time we hit this. And in truth, this only finds one. It's a for loop, but it's a for loop of one. So the for is really just destructuring. We might be able to get away with let this equal this, but probably not, right? We'd have to say like, take one or something like that, unwrap. I don't know. Not going to do it. So that fixes that bug, but then there's the issue that it doesn't understand this visible tiles. Did I call it something different? No, it's right there. Visible tiles. It's part of the view shed. Oh, maybe because point. Let's find out. No, it doesn't understand that. I must have a typo somewhere else then. Oh, I do. Right there. Okay. And main. RLTK point. Okay. And now we're going to see if the monsters can shout insults at me. Hit refresh. And they only... Oh. Yeah, they only shout insults if they can see me. Ooh, right there. Oh, look at that. He's shouting insults. You sit down here in the console. There you go. Cool. All right. So when the monster can see me, he's going to shout insults. If two monsters can see me at the same time, they'll both shout insults. Oh. I guess we can't. It's either that or that pair. I was hoping to be able to get like a double insult. There we go. Yep. See, it's going up by 2 now. Very cool. All right. I'm excited. Get status. Get diff. So what do? We reorganized the imports. We took away the position and added a point. So we never actually used the position before, right? Because it was underbar here, underscore. Sorry. And then we destructure this data. We loop over every monster, and any monster that sees us with its own view shed, every monster has its own view shed. So if it can see us, it'll shout an insult. When the player moves, we update the resource so that the player's position component stays in sync with the point resource that's in the ECS. That's confusing because now like I said earlier, we have 2 different places where we're keeping track of where the player is. And that's always sketchy. Okay, and then we insert, here's where we're inserting the point. Okay, so now get add source, get commit player, monster will only shout insults when they can see the player. Get log. And I think we're going to wrap things up. So we went through up here, turn-based game and tick-based world. So we have it so that the game's systems, right now we have 2 systems, the monster AI system and the visibility system. We have these 2 systems. They only run after the player has done an input. We still clear the screen and draw the screen every tick, right? And maybe that can be done in a different way as well. But we only run the systems after the player's input. So once the player does an input, run state gets set to running. We go through here, we loop back, we run the systems, and then set the state to paused. We draw the screen, again, loop back here, and now the system's set to paused, and we'll get player input. So it's not 100% efficient, but there's no reason to optimize this code because it runs just fine. So there's no reason to do any premature optimization on that. But like the other thing, the double position maintenance, it feels off, and it'd be nice to clean that up when we have a moment to do that. And then we did this quiet monsters until they see you, and that's the code that allows us to check to see if the monster can see the player before doing anything. So we're gonna, obviously this is going to change, to like attack the player or move closer to the player or whatever. So that'll be the monster AI. And then next up is differentiating our monsters, and that'll be for the next stream, hopefully tomorrow. But if not tomorrow, then Friday. So that wraps things up for today. Thanks very much for watching. I'm going to transition this to there we go. And I hope to see you soon.